So I would like to prove this inequality over here, which says that the absolute value of a minus c minus the absolute value of b minus d, this is less than or equal to the absolute value of a minus b plus the absolute value of c minus d for all a, b, c, d elements of real numbers. Okay, so this is true for any four arbitrary real numbers a, b, c, d. Okay, so let's just prove this over here. I would like to do something first, right, for my proof. So actually, let's just start proving it. So to begin, I'll write an equation 1, which is the absolute value of a minus c. I'm going to do a little trick over here. So instead of just a minus c, okay, what I'm going to do is I'm going to subtract and add b. Okay, so I have a minus b and then plus b. Okay, this does not change the value of absolute value of a minus c. Okay, because the negative b, positive b cancel out. But I'm just going to group them in a specific way. So this is the absolute value of a minus b plus the absolute value, oh sorry, what am I saying? Yeah, the absolute value of a minus b plus, and then bracket, just b minus c, absolute value. So all of this is absolute value, okay? And then I'm going to apply the triangle inequality to this expression over here. And I won't prove the triangle inequality here. I'm just going to use it to prove this over here. So this is less than or equal to the absolute value of each of these guys. Okay, so this is less than or equal to the absolute value of a minus b plus the absolute value of b minus c. Okay, cool. So for the second equation, I will do the same thing with the absolute value of b minus d. Okay, and the reason why I'm doing it for these two, because, you know, we have a minus c here, b minus d here, absolute value. Okay, so this is equal to the absolute value of b, and then I'm going to subtract c and add c. Okay, and then minus d, which is equal to the absolute value of b minus c plus c minus d. Okay, and again, applying triangle inequality, this is less than or equal to the absolute value of b minus c plus the absolute value of c minus d. Okay, cool. Well, why is this useful? Well, using equations 1 and equation 2, let us like quote-unquote subtract, okay, equation 2 from equation 1. So what we have is we have the absolute value of a minus c minus the absolute value of b minus d. Okay, and this is going to be less than or equal to, right? Okay, so because since these two on the left side are less than or equal to these two on the right side, when you do a minus c minus the absolute value of a minus c minus the absolute value of b minus d, this will be less than or equal to the difference of the larger guys, okay? Or, you know, they're equal if they are equal to each other, if right hand side is equal to left hand side. Okay, so these are just absolute value properties. And we see here that the b minus c will cancel out, and then we're just left with this minus oh wait, hold on, did I make a mistake somewhere here? Oh no, I did not. Okay, so this is, yes, less than or equal to the absolute value of a minus b, and then minus, right, because we are subtracting this term from this term over here, so minus the absolute value of c minus d, which is less than or equal to, so here we go. The absolute value of c minus d is non-negative, okay? So when you're subtracting the absolute value of c minus d from the absolute value of a minus b, this is less than or equal to the absolute value of a minus b. okay, which is also less than or equal to, the absolute value of a minus b plus the absolute value of c minus d. Okay, so here we have this. Okay, so we get this part, but this is going to be less than this, okay, because I'm adding something to the absolute value of a minus b versus I'm subtracting something, subtracting the same thing away from the absolute value of a minus b. Okay, so this will imply that the absolute value of a minus c minus the absolute value of b minus d, this will be less than or equal to the absolute value of a minus b plus the absolute value of c minus d. Okay, well, that's that part. So we see that's kind of like what we have over here, except that we have still an absolute value around this expression over here in the original statement. Okay, but that's okay, because what I'm going to do is I'm going to lower bound this guy, and I'm going to show you that I can lower bound this guy by the negative of this guy. Okay, so if we can do that, then, well, we'll move on, and we'll see. So from equation 1, what am I going to do is I'm going to actually rearrange it. So what I'm going to do for equation 1 is I'm going to move the absolute value of a minus, where is it? Here. The absolute value of a minus b from to the left-hand side. And I keep on saying equation. These are actually inequations, okay? Inequation. Okay, inequalities. Okay, so these are inequalities, but I think it's precisely called, this whole thing is called an inequation, right? So you have equation, which is, with an equal sign, and inequation with, with these symbols, greater than, less than or equal, greater than or equal, okay? And for sure, they're just called inequalities, okay? So manipulate this inequation, and I get the negative absolute value of a minus b is going to be less than or equal to negative absolute value of a minus c plus the absolute value of b minus c. Okay, so this will be like in equation 3. And then in equation 2, I get, manipulate in equation 2, negative absolute value of c minus d is less than or equal to the absolute value of b minus c, or actually if I stay consistent, negative absolute value of b minus d, and then plus the absolute value of b minus c, okay? Yeah, so essentially I move this part to the right-hand side, and then I move this part to the left-hand side, okay? So that's why there's a negative sign here, and then here there's also a negative sign. So this will be in equation 4. So if I take these inequations and I do in equation 4 minus in equation 3, so let's see what we get here. So we're going to take this, subtract this. So this will be negative absolute value of c minus d. And then when I subtract the negative, it becomes positive absolute value a minus b, okay, plus, okay? And this is less than or equal to, well, the difference of the bigger guys. And, if they're equal to each other, then they'll be the same. Left-hand side, right-hand side equal to each other. That's why we still have an equality sign here for this inequation. Less than or equal to what? So we will have negative absolute value of b minus d. And we see here that b minus c, they'll cancel out. And then we'll have negative, or minus negative absolute value of a minus c, which is plus the absolute value of a minus c. Okay, so why is this helpful for me? Because again, over here, oh, by the way, this absolute value of a minus c minus, so this is the same thing, right? I'm just gonna rearrange this so I get that. Okay, earlier I had negative absolute value b minus d plus absolute value a minus c, which is the same thing as absolute value of a minus c minus the absolute value of b minus d. Okay, which is actually still what's in the absolute value here, okay, in the original statement. So what's really nice here is because, again, we have this negative number here, and I'm adding something, okay? So whatever this number is, okay, if I'm adding something, this will be greater than or equal to that same number, c minus absolute value, negative absolute value, c minus d, minus whatever I was adding earlier, absolute value, a minus b. Okay, you take a number, you add something to it, this will be greater than or equal to, if you take that same number, and then subtract what you were originally adding. So if we read from left to right, it'll be the negative absolute value c minus d minus absolute value a minus b is less than or equal to negative absolute value c minus d plus absolute value a minus b. So this is that. This is what I deduced, okay? So then this would imply that the negative absolute value of c minus d minus the absolute value a minus b is less than or equal to the absolute value a minus c minus absolute value b minus d. So here, due to transitivity, if this is less than or equal to that, and this is less than or equal to that, then this is less than or equal to that. Okay, cool. So what does this mean? I guess I could say this is from star, this will be star, and this will be star star, okay? So I can say from star, equation star, and, or inequation star to, and inequation star star, okay? I get that negative absolute value c minus d minus absolute value a minus b, okay, which is less than or equal to the absolute value of a minus c minus the absolute value of b minus d, which we found over here is actually also less than or equal to the absolute value a minus b plus absolute value c minus d. Okay, which is really interesting because we see here that if I call this number m, then this is precisely equal to negative m. Okay, and I guess I can rearrange it, these two terms, by calling this a minus b and calling this c minus d. Same thing, right? We have two negatives added together, or we have essentially the sum of two negatives. So addition is commutative. Okay, so in this case, I just rearranged these two guys. Okay, so it looks something like that. It's okay, order doesn't matter here. Okay, since these are both negatives, I can rearrange it. If you have something like a minus b, it's not equal to b minus a. But if you, not always, but if you have negative a minus b is the same thing as negative b minus a. Okay, that's trivial. Okay, so we have m here, and then we have, this is precisely negative m, because if you, distribute that negative inside here, you get negative here and negative here in the front, so negative here, negative here, so yes. Okay, what's really cool is because I have this term, okay, but it's sandwiched between negative m and m. And I know that m here is going to be non-negative. So if I call this x. So that this, what I have, this is negative m. So this is what we have here. We have the absolute value. This is equivalent to saying that the absolute value of x is going to be less than or equal to m. Okay, right? Two directions, to be honest, because if absolute value of x is less than or equal to m, then what we get is that x is sandwiched between negative m and positive m, okay, where m itself is non-negative. Okay, m is greater than or equal to 0. Okay, and negative m is less than or equal to 0. Okay, which is cool because what we really have on this side is what is the absolute value of x here? So x here is the absolute value of a minus c, negative or minus, absolute value b minus d. And this is less than or equal to m, which is absolute value of a minus b plus the absolute value of c minus d. Okay, and that is actually my original statement over here. Okay, so there, I proved it. Very neat. And the way I did it initially was to do this trick. So I hope this was cool.